Hello and welcome to this demonstration video of voice enablement with Mobility Platform. In this video we will go through steps involved in creating a Hello World-like voice process in Mobility Platform's Agility toolset in Microsoft Visio, to illustrate how quickly and easily it is to voice enable your existing system with Vocollect talkman. We will quickly go through a high-level overview of how Mobility Platform manages to voice enable your existing system. We will then step through the Hello World voice process we are going to build in this video, and go through each of the steps involved in creating the building blocks, drawing up the voice process flow diagram, and run through the example using Vocollect talkman, and finally a quick wrap-up of this demonstration. At high level, Mobility Platform voice enablement architecture works as follows. Mobility Platform issues SQL script to retrieve data from your business system's database. Data are then rendered and translated to voice instruction according to the process flow defined in Visio diagram. Voice instruction is then sent to talkman device in real time through network socket. Talkman device captures operator's voice input and sends it back to Mobility Platform through the same network socket. Mobility Platform then processes the input based on predefined logic in Visio diagram. In most cases it involves issuing SQL script to your business system's database to update or establish transaction. The process flow engine inside Mobility Platform executes business logic as defined in Visio flow diagram, and injects SQL command to database to achieve real-time bidirectional communication between your existing system and talkman. In the remaining video, we will show you how to build a simple menu ordering voice process using Mobility Platform. Let's quickly go through the use case for this simple voice process. When operator first signs on, talkman will greet operator and ask for the current time in hour. A voice dialog will be something like, "Hello John, what time is it?" If the time responded is before 12 o'clock, voice process will prompt operator to choose from breakfast menu, otherwise it will prompt operator to choose from lunch menu. Both menus will be retrieved from database. Once operator made the selection, voice process will create a new order transaction in the database, acknowledges the order number, and thanks operator for placing the order. It then takes operator back to the beginning to take next order. Just like all programming practices, before we jump into hands-on stuffs, let's quickly sketch out a flow diagram of what we are going to build. First, to greet operators with their names, we will need a function to get operator name from database. Then we pass the name to voice instruction, saying, "Hello user, what time is it?" Next, we will need a comparison logic to determine whether we should give operator lunch or breakfast menu. Both menus will be retrieved from database. Once operator made the selection, we will then need a function to insert the selection back to database, to establish the order, and tell us the order number. Finally, we pass the established order number and voice instruction to confirm, and thank operator for placing the order, then take operator back to the starting point to place next order. Now we have got a flow diagram panned out. Let's start creating the building blocks in Mobility Platform and put everything together. We will need a process object to define the SQL statement to retrieve operator name from existing database, and store the name to a variable that we can reference to later. Mobility Platform provides a web-based agility toolset to maintain all the building blocks needed to assemble the voice process flow in Visio diagram. A separate video will be made available later to go through this web-based user interface. For the purpose of this demonstration, we will focus on using it. Before creating process object to retrieve operator name, we need to first define field variable in the toolset to hold the operator name returned by process object. For now we will create a string type field variable called demo_full_name. Now we are ready to create the process object to retrieve operator name. In technical term, this process object in essence issues a SQL select statement on a user master table for the given operator, and stores the returned value to field variable created earlier. Here we write a very basic SQL select statement to get operator's full name from demo_users table. Note that when writing SQL statement we can use existing field variable value as search criteria denoted with curly symbol. We then add mapping to store operator's full name returned by SQL statement to field variable so that it can be used in our dialog later. The next step is to create a view object representing the dialog that speaks out voice instruction to operator. To make view object creation easier, we can leverage existing dialog templates already available, clone and make necessary change. In this case, since we need a dialog to capture time and hour from operator, we will clone the template that allows user to enter data and make change accordingly. Without going into too much detail on the meaning behind each parameter, let's make a very quick change to the voice instruction text parameter to have this dialog speaking out hello name, what time is it? And since we want to speak out operator's full name, we need to substitute name with field variable defined earlier that holds operator's full name returned by getUsername process object. Note that the dialog definition here is shared by Vocollect talkman, RF scanner and smartphone devices. For now we will make the instruction the same across all devices. The next step is to create a checker object, which contains comparison logic to check whether the hour time reported by operator is greater than or equal to 12. This checker object will use greater than or equal operand to compare value stored in field variable demo_hour to a constant numeric value 12. To produce a list of menu options, we need to create viewList object to specify the SQL query used to retrieve the list from database. Here we can specify the instruction to prompt to operator as well as help text that operator can request via talkman help voice command. In display field we specify the table column containing words that will be displayed or playback to operator when requesting menu option. We will write a simple SQL select statement to retrieve all breakfast menus from table demo_menus. Data returned by this query will populate the menu for operator selection in the dialog. In output value we can specify any other data field corresponding to selected menu option that need to be held in field variable. For example, when operator chose a particular menu name, we need to hold the corresponding menu ID for subsequent process. Since the two view list objects are very similar, it is easier for us to clone the one just created and make minor adjustment to the SQL query statement. In the cloned dialog, all we need to do is modify the SQL statement search criteria to give us lunch menu. The next step is to create a process object to save operator's menu selection into database. For simplicity, we will create a process object that executes SQL insert statement to save menu selection to a table called demo_orders. Note that when transacting with existing business system database, a common approach is to wrap business logic in the form of stored procedure API, and have process object execute the API by passing in field variable as parameters. Here we are writing a small transact SQL block program, or in Oracle terminology PL/SQL block program, to get the new order ID, and pass the value as order number to a field variable so that it can be displayed or spoken out in next dialog. And finally, we need a view object to acknowledge the receipt of menu selection by speaking out the order number. To create this acknowledgement dialog, we will clone an existing template that will simply display or read out the message to operator. Again, without going into too much detail, we simply type in the dialog message we want to read out to operator, and substitute the order number part with field variable demo_order_ID, which will contain the newly created order number returned by place order process object created earlier. Now we have got all the building blocks ready, it is time to put everything together in Microsoft Visio. Using a custom-made Visio stencil, business analysts and developers can drag and drop those building blocks onto Visio flow diagram to create tailor-made voice process flow. Just like in the sketch earlier, the first step is to launch the process object to get operator's full name. Note that when placing process object onto Visio diagram, the stencil will ask whether transaction control is required to ensure transaction consistency when calling process object that will perform data update to database. Obviously we don't need transaction control for this step, which only retrieves data from database. Once the process object is placed in the diagram, we will assign a step number to uniquely identify the step in the flow. Next step, we need to drop in the voice dialog that speaks out greeting with operator's full name and link to the first step. A pre-built generic dialog subflow is also required to translate the dialog definition created into voice instruction. We can drop in this subflow just like all other building blocks. We will save operator's time in our voice input into a field variable that will be used to determine the type of menu to present to operator later. To implement this, we simply drop in another step that sets field variable value to operator's voice input. Now we need to drop in the comparison logic to branch operator to either breakfast or lunch menu. We then drop in the breakfast menu view list object onto the diagram, create a link to the comparison step, and specify no in the link, meaning if the error is less than 12, we will take operator to the breakfast menu, and likewise for the lunch menu, we drop in lunch menu view list object, create a link to the comparison step, and specify yes in the link, meaning if the error is greater than or equal to 12, we will take operator to lunch menu. To create an order after operator made the choice, we need to drop in the place order process object and link it to both menu dialogs. Since this process object is performing transaction on database, we will specify yes in transaction control to only commit the change when entire transaction completes. And finally, we will drop in the voice dialog that speaks at acknowledgement message. Use the same pre-built generic dialog subflow to handle message rendering to talkman device, and link it back to the starting point to capture next order. After finishing the drawings, the last step is to save file and upload it to Mobility Platform Engine. For this exercise, we will call this voice process demo_menu_order. This will become our entry point for talkman device, which will be set up in Mobility Platform's device management console later. In our web-based agility toolset, we will now upload the finished Visio drawing to Mobility Platform Engine for compilation. This is the last step in the development process. The new voice process is ready. Now we need to make talkman device aware of this new menu ordering process we just created. This is done inside Mobility Platform's device management console. Here we simply update the device setting to make our new process the entry point for this talkman device. After all the hard work, we are now ready to test drive the menu ordering process using talkman device. In talkman device, we will first switch to operator 1001 to walk through the menu ordering process.
Press the plus 1002, 1001, loading operator. Loading voice templates, please wait. Current operator is 1001, good night. Please keep quiet for a few seconds. Please say 0,
0,
1,
1,
2.
2.
Hello John Doe, what time is it?
Here you can see on talkman initialization, it launches menu ordering process we just developed, and the first voice dialog speaks out operator's full name as defined in the database.
1, 1.
Please choose menu option.
Option.
01, big breakfast.
Ready.
02, buttermilk pancake.
Ready.
03, eggs benedict.
Ready.
04, fresh fruit salad.
Ready.
01, big breakfast.
As operator says it is 11 o'clock, our voice process retrieves breakfast menu list from database for operator to choose from. In talkman device, operator uses simple command to navigate through options and make selection.
Select.
Big breakfast correct.
Yes.
Your order number is 2015011012. Thank you.
As expected, talkman speaks at acknowledgement message, along with newly created order number from database.
Ready.
Hello John Doe, what time is it?
Once operator acknowledges the message, our voice process takes operator back to the beginning. Now let's try to order something for lunch.
1, 3.
Please choose menu option.
Option.
01, Caesar salad.
Ready.
02, chicken sknits.
Ready.
03, fish of the day.
Ready.
04, lemon pepper squid.
This time round, because operator says it is 1 p.m., our process gives operator lunch menu to choose from.
Select.
Lemon pepper squid correct.
Yes.
Your order number is 2015011013. Thank you.
Again, our voice process creates new order in the database and speaks out order number to operator. This concludes our demonstration. We hope throughout this video you will find Mobility Platform has the right tool set to help your business fast-forward voice process development, using standard SQL language to perform real-time transaction with existing database, along with Visio flow diagram to control voice application logic and dialogue navigation. Also as an add-on, the same voice process developed can be deployed to other types of handheld devices, such as RF scanner, smartphone and tablet. We will demonstrate this multi-device deployment feature in a separate video. With Mobility Platform's Agility toolset, you can create and deploy your specific voice process much quicker and faster, compared to conventional implementation and development approach, and you can quickly modify the process to adapt change in your business needs, and make the same function available to different types of mobile devices in one simple development exercise. And since the development requires only standard SQL language and Visio flow drawing knowledge, the entire voice process implementation cycle will be shortened with less development effort and cost. This in turn translates to lower total cost of ownership to your business when it comes to future maintenance and enhancement. Thank you for watching this demonstration video. For further information on how we could help to quickly voice enable your existing system, please contact us on info@upimium.com.